Good morning, my dear friends. As you know that this is Virat Kumar, lecturer in Electrical and Electronics Engineering. In the previous session, we have completed the conic sections of one part, that is regarding ellipse, and today we will see about parabola, and we have discussed briefly about parabola, like how many methods are there, what is the general method, like that. We will see it again. See, this is the part of parabola. We have generally three methods in it. One is rectangle method, the second one is methods of tangents, it's nothing but a triangle method, and the third one is basic locus method or directed focus method. The third one is the general method to all the conic sections, nothing but all the engineering curves. So these are the three methods involved in making or drawing parabola. So as we have seen how the parabola looks, so this is the center axis of the cone and the section plane parallel to end generator. There are two end generators. This, if a section plane is cut in parallel either to this or this, that cutting plane should be in parallel to the section plane. So section plane parallel to end generator. Then after the cutting portion was got removed, then we will see the part in the parabola and the parabola order. So this is the parabola. So this is our parabola. Okay. Okay, then we'll move on to the methods to make the parabola. Firstly, to the rectangle method. Parabola by using rectangle method. As usually, we'll just not go into the theory concept of this, we will directly move into the problematic. So by making a problem in it, we can just analyze the theoretical concept in it also. So it's a problem number 7 in these geometrical constructions in the conic sections. So problem number 7 is a ball thrown in air attains 100 meters height and covers horizontal distance of 150 meters on ground. Draw the path of the ball, nothing but the projectile. See what he's saying, a person has thrown a ball into the air of about 100 meters height and it covers a horizon, and he thrown to a other person who is ready to catch the ball. So and he is about a distance of 150 meters to him. So that ball covers the horizontal distance of 150 meters on ground. So from one person to the other person, the height of the ball was attained is 100 meters and the distance to that person is about 150 meters. So he is just telling us to draw the path of the ball, how it is projected from that person to the other person. So that path is called a parabola. So we need to make that path. See, there are some steps involved in it. There are 5 steps in it. We will see one by one. The first step is draw a rectangle of above size and divide it into 2 equal vertical parts. He is telling us to draw rectangle. We have got 2 dimensions over here, 100 mm and 150. So the larger one, length and breadth. So by that we can draw a rectangle of above size and divide it into two equal vertical parts. And consider left part for construction and divide height and length in equal number of parts and name those as 1, 2, 3, 4, 5 and 6. So join vertical 1, 2, 3, 4, 5 and 6 to the top center of rectangle. The fourth step is similarly draw upward vertical lines from horizontal 1, 2, 3, 4, 5 and wherever these lines intersect, previously draw inclined lines in sequence, mark those points and further join in smooth possible curve. So repeat the construction on right side too and join all the sequences. So the obtained locus is a parabola. Okay, we will see the construction. What is saying? Firstly, to draw a rectangle of the above size, we have drawn a rectangle and he said us to divide that rectangle into two equal vertical parts. Okay, we have done it, and he is telling us the left part of the construction, divide the height and length in equal number of parts, for example 6 parts. So he is just making. So we have obtained 6 equal parts and name them. Similarly to the bottom face also, and name them 1, 2, 3, 4, 5 and 6. Similarly to the bottom 1, 2, 3, 4, 5 and 6. Now from the middle point to the 1, 2, 3, 4, 5 and 6, I draw a inclined lines 1, 2, 3, 4, 5 and 6 is only a horizontal line. Similarly do the same process towards your right also. Okay, now from the bottom face of 1, 2, 3, 4, 5 and 6, draw the vertical lines to that inclined lines in order to intersect. After intersecting, you just mark the points. See, it's 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5 and 6 to 6 is already existing. Now mark the points. Now join all these points in order to obtain a smooth curve, which is called a parabola. So this is the trace of the ball thrown in air, which attains 100 meters of height and covers a horizontal distance of 150 meters on ground. So the obtained projectile is a conic curve called parabola. This is done through a rectangle method. I hope you have got the point, or else we'll see the construction once again. Okay, firstly he said us to draw a rectangle with the given dimensions and said us to divide this rectangle into two equal parts vertically, and towards the left, vertical and horizontal lines, divide them into 6 equal parts. And to the horizontal line also, then name them as 1, 2, 3, 4, 5 and 6. Similarly to the horizontal line. Now from the center line, draw the inclined lines to 1, 2, 3, 4, 5 and 6. So 6 is already done. Repeat the same procedure towards your right. Now make the vertical lines from the horizontal line 1, 2, 3, 4 and 5 and 6 to the inclined lines of 1, 2, 3, 4, 5 and 6. So intersect 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5 and 6 to 6 is already existing, and mark the points for each. 6 to 6 is already existing. Similarly towards your right, mark the points clearly, so that it should be only towards 1 to 1, 2 to 2, 3 to 3, and should not miss this sequence. The point should not be from 3 to 2 or from 4 to 3 or 4 to 5 or etc. It should be only towards 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5 and 6 to 6. And if you just mark from 3 to 4 or something, or from 2 to 1 or something, then it would be the wrong marking and you will be not obtaining any parabola. Similarly towards the right, now join all these points smoothly to obtain a curve called parabola. See how neatly it was obtained. Okay, have got the point. I'll just give you 2 minutes of time, so make it fast. Sorry. Okay, then we'll move on to the next topic, or else the next method. So this is our required parabola. Okay, now the next method is drawing a parabola by triangle method or method of tangents. So similarly, not moving into the theoretical concept, we'll directly move into the problem. So draw an isosceles triangle of 100 mm long base and 110 mm long altitude. Inscribe a parabola in it by method of tangents. So it's telling us to draw an isosceles triangle. And what is an isosceles triangle called? If any two sides of a triangle is unequal, then it is called an isosceles triangle. So draw an isosceles triangle of 100 mm long base and 110 mm long altitude by the axis. So inscribe a parabola in it by the method of tangent or triangle method. We'll see some relevant steps to draw the parabola by using method of tangents. So there are only 5 relevant steps to it. The first one is construct the triangle as per the given dimensions. As already here just mentioned, 100 mm is the base and 110 mm is long altitude, which is the center of it, and at the top of the 110 mm we'll just make an inclined lines towards the base. Then you will obtain an isosceles triangle. Then he is saying is in the second step, divide its both sides into same number of equal parts. The inclined lines are to be divided into some equal number of parts on the either sides. And then in the third step, name the parts in ascending and descending manner as shown. We will be showing in your figure. Ascending and descending is from small to big and big to small, nothing but we'll just make from 1 2 3 4 5. If we are making in 6 equal parts, we'll just 1 2 3 4 5 6 from C ascending to, this is an ascending order, small to big, and in the next side we'll just make from descending order from 6 5 4 3 2 1. So this is called a name the parts in ascending and descending manner. Will be showing in the figure. This will be our, this is your center line, which is of about 110 mm, and this is your 100 mm line. Okay, so this is in ascending order and this is in descending order. This is an ascending order and this is descending order. So it's just telling us to name the parts in ascending and descending manner as shown. So now join 1 to 1 is already there, 2 to 2, 3 to 3, 4 to 4, 5 to 5. Not exactly, I think. Okay, from this ascending and this is descending. Okay, 1 second. So join all 1 to 1, 2 to 2, 3 to 3 and so on. Now draw the curves as shown, therefore tangent to all these lines, therefore all lines being tangents to the curve. It is called the method of tangents. So we'll see the diagram. So firstly we need to make an isosceles triangle with the given dimensions. On this land side, divide them into some equal number of parts. Similarly towards your right, and name them from A to C, the ascending order, and from B to C it is in the descending order. So similarly join from 1 to 1, 2 to 2, 3 to 3 and so on to 14 to 14. Now you can clearly see the middle part. So you need to draw a tangent to the curves. See here how we are drawing a tangent. So this is the required parabola for the method of tangents. So okay, is it clear? I will see it again. Firstly we need to draw an isosceles triangle, name them A, B, C. There are two slant sides, divide them into some equal number of parts. From A to C, see from A to C it is in the ascending order, and from B to C it is in the descending order. See, 1 to 14 is ascending order and 14 to 1 is descending order. Now I join 1 to 1, 2 to 2, 3 to 3, 4 to 4 and so on up to 14 to 14. To 14. Now draw the curve as shown, therefore tangent to all these lines. So the above all lines being tangents to the curve, it is called a method of tangents. So you need to make a tangent to all these lines, so in order to obtain a parabola. So this method is called as method of tangents, or either it is a method, the other name for this is triangle method. So this is your required parabola, just note it down. Okay, then we will move on to the next topic. Okay, now here we need to draw a parabola by using directrix focus method. Directrix focus method. Similarly, we will move on to the problem directly. So there is a problem here. Point F is 50 mm from a vertical straight line of AB, which is nothing but the directrix. I draw locus of point P moving in a plane such that it always remains equidistant from point F and lies on line AB. So we will see some steps involved in it. The first step is locate center of line perpendicular line to AB from point F. This will be initial point P and also the vertex. Mark 5 mm distance to its right side. Note those points 1, 2, 3, 4 and from those draw lines parallel to AB. Mark 5 mm distance to its left of P and name it as 1. Now take O to 1 distance as radius and F as center. Draw an arc cutting first parallel line to AB. Name upper point P1 and lower point P2. So FP1 is equals to O to 1. So similarly repeat this procedure by taking again 5 mm to right and left and locate P3, P4 and so on. Join all these points in a smooth curve in order to obtain your required parabola. It's okay. We'll see the diagram firstly and then you can make easily. So firstly draw a line AB, which is nothing but your directrix, and draw a horizontal line from the center of 50 mm and locate a point of about 50 mm distance as F, which is nothing but your focus, and exactly at the center you locate another point and mark it as V, nothing but the vertex. So therefore OV is equals to VF. So here the eccentricity is 25 by 25, nothing but eccentricity is equals to 1. So yesterday we have seen eccentricity 2 by 3, nothing but 20 by 30, which is less than 1. So if eccentricity is less than 1, we obtain the curve ellipse. If eccentricity is equals to 1, we obtain the curve parabola. So this is thing, and drawing the lines. So this is the vertex, and dividing some beyond vertex towards your right, mark some points 1, 2, 3 and 4, and draw the vertical lines that one parallel to directrix, 1, 2, 3, 4 and so on. Similarly towards your right. Now he is telling us to O2, take O to 1 distance as radius and F as center, draw an arc cutting first parallel line to AB, so that points are P1 and P2, and next from O to 2 as radius and F as center, cut the second parallel line in order to obtain the points. Similarly O to 3 as radius, F as center, cut the arcs on both upper and lower in order to obtain the points. Similarly O to 4 as radius, F as center, cut the arcs and fourth parallel line to the directrix. So we obtain some points and join all these points smoothly in order to obtain the curve called parabola by using directrix focus method. So is it clear? Okay, I'll just show you the diagram once again. So firstly you need to make a vertical line of AB, which is called directrix, and from the center you draw a horizontal line of 50 mm. At the end you mark a point and note it as F focus, and exactly at the center mark a point and look at it as V vertex. So here O to V is equals to V to F. Since OV is equals to VF, so the value of eccentricity is equals to 1 in order to obtain the parabola. Now beyond V, towards your left, mark some points 1, 2, 3 and 4. They need not to be any equidistance, and from 1, 2, 3 and 4 draw the vertical lines which are parallel to the directrix. So it's 1, second line, third line and fourth line. And now the procedure is O to 1 as radius, see, O to 1 as radius, F as center, draw the line to P2, one line in order to obtain P1 and P2 point. See, O to 1 as radius, F as center. We'll cut some arcs on the first line on both upper and lower in order to obtain P1 and P2 points. Similarly, O to 2 as radius, F as center, will cut the second line both on upper and lower in order to obtain some points. Similarly, from O to 3 as center, O to 3 as radius, F as center, cut the third line on both upper and lower in order to obtain the 2 points. Similarly, from O to 4 as radius, F as center, cut the arc on fourth line, will obtain some points. So join all these points smoothly in order to obtain a curve called parabola by using directrix focus method. This line is called directrix. X. This line is called directrix. This line is called directrix, and this line is called focus. Okay, so this is your required parabola by using directrix focus method or basic laws method. So this is a general method to all the conic curves or engineering curves like ellipse, parabola and hyperbola. So since we have only 3 methods in our parabola, so I think it's almost done with the 3 methods. So I'll just give some time to note it down. Okay, so shall we summarize the today's topics? Okay, or else shall we move on to the next new topic, or else I'll just make the new topic in your next session. So now we'll just summarize the today's topics. See, this is your rectangular parabola by using rectangle method. I'll just show you once again. That is your question, and this is your relevant steps to it. We have seen a rectangular box and dividing this rectangular box into 2 equal vertical parts, and towards your left the vertical line and horizontal lines towards your left, divide them into 6 equal parts, both the vertical and horizontal line, and mark them as 1, 2 and 6. Similarly to the horizontal sections. Now from the center top, draw some inclined lines to the vertical line of 1, 2, 3, 4, 5 and 6. Repeat the same procedures towards your right rectangle. and from the bottom horizontal lines towards your left and right you have 1 2 3 4 5 and 6 lines. Draw the vertical lines in order to intersect those inclined lines. So you need to extend from 1 2 3 4 and 5 6 vertically in order to intersect those inclined lines, and that only from 1 to 1 and 2 to 2, 3 to 3, 4 to 4, 5 to 5 and 6 to 6. Repeat the same procedures towards your right, and at the intersection you just mark the points clearly, smoothly, clearly. And join all these points smoothly in order to obtain your required parabola by using rectangle method. Is this clear? So in your methods of tangents, the parabola by using methods of tangent, you need to draw a triangle, isosceles triangle, and mark it as A, B and C. Divide AC and CB lines into semi-equal number of parts and denote the points A to C is in ascending order and B to C in descending order. See? Okay. Now join 1 to 1, 2 to 2, 3 to 3 and so on to 14 to 14. So on to 14 to 14. Now since it is a method of tangent, you need to draw a tangent line to all these lines. Draw a tangent to all these lines in order to obtain your required parabola. See, this is your required parabola. Is it clear? And then we have moved to the third step, which is nothing but the directrix focus method. In this, firstly we will draw a directrix, a vertical directrix line of AB, and from the center to it draw a horizontal line, nothing but the focus of about 50 mm. At the end you just mark a point and locate it as F, nothing but the focus, and exactly OTF will be 50 mm, and exactly at center you just mark a point and locate it as V, nothing but the vertex, so that OV is equals to VF. This indicates that the value of eccentricity is equals to 1. So that means in this you obtain a curve called parabola. Now from the right towards your V, mention some points of 1, 2, 3 and 4 may not be in equidistance, and draw some vertical lines which are parallel to the directrix. Now taking O to 1 as radius, F as center, cut the one line both on upper and lower in order to obtain P1 and P2 points, and mark the points. Similarly, O to 2 as radius, F as center, cut the line 2 on both above and below. So repeat all the steps similarly to the fourth line, up to the fourth line. Now join all these points by intersecting by joining your vertex V point in order to obtain a smooth curve called parabola. See, this is your required parabola. Is it clear? Okay, so this is about the parabola session. We have only 3 methods in it, and the next topic is hyperbola. We will see a light introduction of it. So this is your hyperbola, and the same in this also we have only 3 methods to make it. The first one is rectangular hyperbola, nothing but the coordinates given, and the second one is rectangular hyperbola with PV diagram, nothing but equation given, and the third nothing but the general method called basic locus method or directrix focus method. So there are totally 3 methods involved in hyperbola. This will be light complicated, will not be much easier than your parabola. So this will be seeing in our next session and the tomorrow's session. So we have 3 methods in it. First one is rectangular hyperbola by using coordinates given, and the second one is same rectangular hyperbola by using PV diagram and the equation given, and the third one is general method, nothing but the basic locus method or directrix focus method. We will see how a hyperbola looks. We have seen about how the ellipse looks and how the parabola looks. Now we will see about how the hyperbola looks. Similarly, you just take a cone and cut the cone vertically, and the section plane should be in parallel with the axis line. See, the section plane parallel to axis, and if you remove the cutting part and you just observe the cone, you will be seeing a curve which looks in the order of hyperbola. See, this is your hyperbola. This curve is called your hyperbola. See, that curve is called your hyperbola. Is it clear? Okay, we'll see it again. Take a cone and cut the cone in a section plane which is parallel to your axis line. See, section plane parallel to the axis line. Then if you see, by removing the cutting section, you will be observed a curve which looks in the order of hyperbola. See, for we have seen for ellipse the eccentricity value is less than 1, that by 2 by 3, and for parabola we have seen the value of eccentricity is equal to 1, 2.5 by 2.5 equally displaced, and for hyperbola the value of eccentricity is greater than 1. That means we need to take 3:2, 30 by 20. Okay, so these problems refer problem number 6, 9 and 12 for all these. So this is a general method, so we will be seeing these methods in the next session. Okay, thank you one and all. So we'll see the methods of hyperbola in the next session. I hope you have understood very well in this session. So that's it for today's session. So thank you one